The James Webb Space Telescope of NASA continues to astound the globe with its deepest infrared photos of the cosmos. Observing stars and galaxies that have passed away before their light reached the huge telescope, the image transports viewers billions of years into the past. Once again, welcome back to Theory of Science. We shall learn more about the James Webb Space Telescope, which is able to observe the farthest planets and universes present outside the Milky Way today. You may learn more about these discoveries by watching the video to the end, giving it a like, and subscribing to our channel for more engaging material. The 10-year wait for the $10 billion James Webb Space Telescope's launch on Christmas Day 2021 was both thrilling and worrisome for the tens of thousands of scientists, engineers, managers, and support personnel who worked on the mission up to this point. They shared my anxiety as the head of the council overseeing the JWST Operations Center, the Space Telescope Science Institute. The JWST has a lot of scientific potential and could provide answers to some of the most important cosmological puzzles. Although scientists prefer thinking of JWST in that way, it usually refers to as the Hubble Space Telescope's successor. For more than 30 years, Hubble has been in operation, providing us with breathtaking views of the cosmos and countless scientific discoveries. It will hopefully keep running for many more years, as we predict. However, compared to ground-based telescopes, its sensitivity and capacity to view the faintest objects are constrained by the relatively tiny 2.4-meter diameter mirror. Although Hubble can observe infrared light to a certain extent, it cannot access the light wavelengths from the first stars and galaxies, but JWST will be able to achieve that. Even population 3 stars that have never been seen before might be visible. One of the main scientific aims of JWST is to answer the critical scientific question of when the first stars formed shortly after the Big Bang and how they produced the basic elements of the first galaxies. The components necessary for life and contemporary technology like carbon, silicon, and gold were ultimately produced in early stars, although the exact process is still unclear to us. The observatory's scale, wavelength coverage, and need to be kept extremely cool to reduce unwanted background light were all influenced by the need to detect faint objects in the furthest reaches of the cosmos. JWST will conduct other scientific programs besides studying the first stars and galaxies. It is intended to be a multi-purpose observatory where astronomers worldwide can request time to do research. When JWST observes in the infrared, for example, it can see through dust clouds that surround very young stars and are opaque to visible light. Unlike Hubble, it will have direct access to stellar nurseries, the sites of the birth of stars, and the planetary systems that support them. The observations will provide insight into the processes by which star formation and planetary systems orbiting stars are initiated, as well as how dust and gas clouds collapse to generate stars. When the earliest JWST designs were debated more than 20 years ago, there were no known planets other than those in our solar system. Since then, thousands of planets in our galaxy's other stars have been found by scientists. The JWST observing schedule will devote much of its time studying these planets' atmospheres. JWST has a significant advantage in comparison to Earth-based observatories because of its wavelength coverage, which is especially well suited to investigating chemicals in extraterrestrial atmospheres and the weak infrared background from space. There are 2 methods available. One uses that planets occasionally move in front of their parent star, causing a decrease in the star's brightness that we can observe. We can examine a planet's atmosphere to determine what molecules are present by precisely breaking down the light by wavelength before and during a passage. Another technique makes it possible to directly image the planet and analyze its atmosphere or surface by employing a chronograph. This specialized device blocks the light from the parent star. This could reveal whether a planet is habitable, possibly requiring further research and the eventual deployment of tiny space probes. The ultimate goal is to discover a planet like Earth, but doing so would need a very fortunate confluence of events because such planets are probably uncommon in the solar neighborhood and are quite faint compared to their parent stars. Most likely, JWST will investigate ice or gas giants like Uranus and Neptune in our solar system, or gas giants like Jupiter and Saturn. None of the other planetary systems is anything like our own, with many massive planets orbiting at tighter distances, their atmospheres being heated to greater temperatures, and their weather being more changeable. JWST will be able to examine our solar system in addition to investigating worlds outside of it. Due to its high sensitivity, comets and other ice things in the solar system's outermost regions can be recognized and described. These objects, which have remained virtually intact since their development in such a remote place, may hold information about the formation of Earth, including the origin of its water, which may have resulted from bombardment by such bodies early in the planet's history. The JWST will also be able to examine the atmospheres and seasonal weather fluctuations of all the planets outside of Earth's orbits around the Sun. The expenditure of constructing a bold, game-changing telescope like JWST must be justified in detail, along with proposals for what will be discovered. There will, however, be discoveries that no one can predict. When Hubble was first launched, exoplanets were virtually a science fiction idea, but studying them was one of its key goals. The first region of the sky, roughly the size of a sand particle held at arm's length, is covered in the first photographs transmitted by the Webb Space Telescope. It makes up a very little portion of the entire universe. What unforeseen scientific findings may we expect from the JWST? Don't forget to subscribe to our channel and hit the bell for additional information about such discoveries.